Okay, we have an interesting integral from the MIT Integration Bee 2019, problem 14. We have the integral from 0 to pi over 100 of sine 20x plus sine 19x over cosine 20x plus cosine 19x dx. Okay, first this one looks pretty intimidating, especially with this, the upper bound pi over 100. It's not clear what we can do with that. But thinking about it a little bit, we've got this similarity where we've got the same angles, 20 and 19 on each of these. I think we can clean this whole thing up with a couple of trig identities. Okay, so we have our two trig identities on the board, and I've just written it the way we normally see these, or the way I normally see them. But what I want to notice, because like I said in our original problem, we've got the same symmetry of our angles, 20 and 19. So what's happening is this part right here is looking a lot like our numerator, and this part right here is looking a lot like our denominator. And what we want is we want a plus b to be 20 and a minus b to be 19. But now one thing we can do to get it a little more looking like our problem, let's multiply by 2 on both sides everywhere. That way we can get rid of this 1/2, and now this is exactly what we want for our numerator. So we'll use the formula kind of going like this in the other direction. The only question is when we use this, what is a going to be and what is b going to be? So for this to work the way we'd like it to work, we want a plus b to be just equal to 20x, and then we want this part, a minus b, to be 19x. So we have a minus b, 19x. Two equations, two unknowns. One convenient way to do it is let's add these two together. So that way the b's cancel. We end up with 2a equals 39x. Divide by 2, and we get our a value, 39x. Now doing it the other way, if you subtract these two equations, then the a's cancel. You end up getting 2b. I'm just kind of doing it on the fly. When you subtract these right here, 20x minus 19x, you just have 1x, so our b value is going to be x over 2. And so you see, using this a and b value, this is going to make sense. You add these together, you're going to get 40x over 2, which is our 20x. You subtract them, you get 38 over 2, which is going to be our 19. And so now that we have this a and b value, we can just go to this formula and use this here and this right here, plug it into our integral, and then we should be able to get some really good simplification. Okay, so now that I've rewritten this integral using the formulas here, plugging in with our a and b values, now we can get some cancellation because we've got 2 in front of both these, so of course we can cancel 2's here. And then here we've got cosine x over 2 over cosine x over 2, we can cancel this with this here. So it turns out the whole thing, this is going to be the same thing as just tangent 39 over 2x. So then let's just go ahead and integrate it. If you're integrating tangent, we could just use the formula. That's going to be like natural log of secant. I think I'm going to do it the other way. I'm going to do it as minus natural log of cosine with this input 39 over 2x. But then we just need to be aware of this input and take the reciprocal and bring it out front. So what's going to happen, let me get rid of that for a second. Well, this will be 2 over 39 in front. We still have this minus sign. And we just need to evaluate from 0 to pi over 100. Well, for the 0 part, that's not going to matter because you're going to have cosine of 0, which is just 1. Natural log of 1 is 0, so this part goes away. But now when we plug in pi over 100, I don't think we can really do too much to simplify it. So I'm not quite sure why they did that because it's not that nice, but I guess maybe sometimes math isn't that nice. So we'll just put up with it and plug it in. So what's going to happen is we're going to get 39 pi, 2 times 100 is 200. And so for my final solution to this, we just get minus 2 over 39 natural log cosine 39 pi over 200, and that's it. Okay, so there you have it. Kind of surprising. Usually we expect the answer to be like natural log of 2019 or something, but in this case we end up with 39 pi over 200. If I remember, I'll put this in my calculator and see what it is as a decimal solution. But in the MIT solution key, they just have it like this. They just left it unreduced with cosine 39 pi over 200. Just because clearly it's not going to be like a nice value for this thing right here. Okay, that's it for today. Thanks everyone for watching. Have a good day.